Welcome to our note packet for Module 3, Proportions and Similar Figures. I will have these available for you to pick up after November 9th in class, or you may print them from Canvas. Let's go to page 2 in our notes and go through these problems together. We're starting out with ratios and proportions. A ratio compares two different numbers. When writing a ratio, order matters. You express the ratio in the same unit and in simplest form. Okay, we're going to find some ratios of numbers of pictures we have here from the movie Finding Nemo. So we have Nemo, this little clown fish here, there's 3 of those. And we have his friend Squirt, the sea turtle, 2 of those. And then we have Dory, the blue one here. Okay, so let's count the number of pictures we have and find the ratios. So again, remember, order matters. If we're doing the ratio of Nemo to Squirt, then we need the top number of our ratio to be the number of Nemos and the bottom number of our ratio to be the number of Squirts. So there's a couple of different ways we can write this. Typically, a fraction is the easiest thing to work with. It doesn't have to be written that way, but if I was going to write this as a fraction, I would do 3 Nemos to 2 Squirts. So that's a 3 to 2 ratio. Another way to write a ratio is with a colon, like we would do 3 to 2. But writing it as a fraction like this allows us to use it to solve things a little easier. The ratio of Dory to Nemo. So we have 1 Dory and we have 3 Nemos. So I'm going to do a 1 to 3 ratio. So 1 Dory to 3 Nemos. Notice how I'm putting the first number on the top of my fraction and the second number on the bottom of my fraction. How about the ratio of Squirt to all of these Nemo characters? So we have 2 Squirts compared to all of these pictures. So 1, 2, 3, 4, 5, 6. So 2 out of the 6 pictures are Squirt. Now, if we can reduce our ratio or our fraction, we should always do that. Notice how 2 over 6 can reduce because both the 2 and the 6 are divisible by 2. And that will give us another ratio of 1/3. So not only is there a 1 to 3 ratio of the number of Dorys to the number of Nemos, there's also a 1 to 3 ratio of the number of Squirts to all of the pictures here. So every 1 out of 3 pictures is Squirt. A proportion is an equation that states that 2 ratios are equal. So the problem we just barely did, where we said that 2/6 was equivalent to 1/3 because we reduced the 2/6, we simplified it down to 1/3, that is actually a proportion. And that tells us that 2 ratios are equal to each other. Okay, in order to tell if 2 ratios make the proportion, we can cross multiply. So I want to know if 6 over 24 is the same thing as 5 over 25. So if you cross multiply and you get the same number on both sides, then it is a proportion. And if you don't get the same number, then it's not a proportion. The problem I just barely did, if I cross multiply 3 times 2, I get 6. And if I multiply 6 times 1, I also get 6. So since both of those products equal 6, that means that this proportion is true. It is equal, and the 2 sides are equivalent. Okay, let's try this one. Let's multiply 6 and 25. 6 times 25 is 150. Sometimes when I'm multiplying by 25, I think of it as a quarter. So 6 quarters would be $1.50. So we're trying to figure out if multiplying those 2 numbers together is going to give us the same answer as multiplying these 2 numbers together. So 5 times 24. Another way to do that is to double the 5 and get 10, and half the 24, which is 12. So 12 times 10, that would be 120. Let's check that in my calculator. 5 times 24 is, in fact, 120. So did we get the same number when we cross-multiplied each side? We did not. We got different numbers. So that means that this is not a proportion. No, not a proportion. Okay, let's try this other one. 4 times 36 is 144. And then 9 times 16 is another 144. So it didn't matter which sets of numbers I multiplied together, I still got 144. And I show that each side is equal to the other side, or the means and the extremes multiplied together are equal. And that tells us that this is a proportion. And basically, proportion, what that means is that 4/9 is a fraction that's equivalent, a reduced fraction for 16 over 36. Now let's use cross-multiplying to help us solve some proportions. Solving proportions, we can use cross-multiplication to find unknown values in a proportion. Let's just do a few of these together. So if I cross-multiply 9 times 14 and 2 times a, first of all, a is a number in disguise. We don't know what it is. So when I multiply 2 times a, I don't get an actual number out of that. I just get 2a, meaning 2 times whatever the value of a is, right? But then on the other side, I can multiply these together. So 9 times 14, I'm going to use a calculator for that, is 126. Notice how I've gotten rid of the fractions in my problem, in my proportion problem, by cross-multiplying. Cross-multiplying is really awesome to get rid of fractions, because many of us are not very comfortable with fractions. So now we have a linear equation that we learned how to solve earlier this year, or we reviewed at least how to solve it. It's something you've probably learned in a previous math class. But now all we have to do is remember those skills where we need to get the value of a by itself. So to do that, we're going to divide by the coefficient multiplying the a. So we're going to divide both sides by 2. So 2 divided by 2 is 1. That leaves us with a singular a. Give us the value of that. And then 126 divided by 2, feel free to use a calculator if you need to, is 63. So we found the value of a that makes this proportion true. 9 over 2 is the same thing as 63 over 14. That gives us equal ratios on each side. These are all very similar types of problems. Let's do one that has some negatives in it. So skipping down here to problem 4, I'm going to cross multiply negative 2 times x and then negative 10 times 3. Again, by cross multiplying, I get rid of the fractions, right? Cross multiplication is a property that tells us that the proportions are true, that they are equal to each other. So once we use that property, we don't need to have the fractions anymore. Now all we need to do is divide that negative 2, and we get x equals 15. So 15 is the number we could put in place of x and have proportions. So 15 over negative 10 is equal to 3 over negative 2. Those are equal ratios. All of these problems are very similar. Let's do one of these, though, that has a fraction on one side, but not a fraction on the other side. Maybe just number 5. So the first thing I like to do when I have a problem that has a fraction on one side, but no fraction on the other side, is to actually turn it into a fraction by putting it over 1. Then I can go ahead and do my cross multiplying. So on one side I'll have 1 times 36, and on the other side I'll have 3 times x. Now it doesn't matter which side I write which number. I could write 36 equals 3x, or I can write 3x equals 36. It does not matter which way I do it. The important thing is for this problem that even though I didn't have a fraction, I can turn it into a fraction by putting it over 1, and then I can still do my same cross multiplying process. So now my last step is to divide by 3, and then 36 divided by 3 is 12. So the value of x that makes this proportion true is 12. You can see down here that the problems can get even more complicated with more variables and more numbers. We'll go through those as a separate video here in just a